In this video, we're going to talk about symmetry. So there's three different types of symmetry. The first one being line symmetry. So in general, symmetry means that it matches up over a specific spot. So if we're talking about line symmetry, that means that your figure is going to match up if you flip it over a specific line. So for example, these two figures have line symmetry. Because if you look at this white line here, if I take, just looking at the butterfly, not the entire image, but if I take this portion of the butterfly and flip it over that line, it'll match up on both sides, meaning it has line symmetry. Same thing with this figure. If I take this section and flip it over this vertical line, it'll match up. And if I fold along this horizontal line, the same thing will happen. So basically taking the top and flipping it over this horizontal line, it'll match up. So it's basically, imagine folding your paper in half along a specific line, and if the image matches on both sides, that means it has line symmetry along that folded line. So if we look at these examples here, if you imagine taking this letter A and folding it along a vertical line, so the vertical line would be going through that point, this would have line symmetry because if I folded along this line, it would match up. So if you're having a hard time visualizing this, what you can do is you can actually take your paper and fold it and see if the left-hand side will match with the right-hand side. If I look at the letter H, it'll have line symmetry along this vertical line. So if this vertical line is in the center. And it's also going to depend, we could have a horizontal line if these pieces are the same. So if this length right here is the same as this length, then when I fold the top half down, it'll match up. So I'm going to go ahead and assume that those are the same, and I'm going to draw in a horizontal line of symmetry as well. Oops. So it really depends on this being the same as that though. So if I were to fold along this line, the top would match up with the bottom. The next one, I'm going to look at the whole word mom. So if I folded along vertically along the center of this O, then this section will match up with this section. The two figures below, the triangle here, if I assume that this is an equilateral triangle, meaning all three sides are the same, that means that I'm going to have three lines of symmetry. So I'm going to have one that's pretty easy to see right through the middle. So if you fold the top, fold along this line, this left side will go to the right side. I can also do one through this vertex, a line of symmetry, and I can also do one through this. So if I were to fold along this line, then this side will match up with this side. Now remember, I don't know that these are exact. I'm just kind of estimating this based on what I see. And then the last one here, I have a vertical line of symmetry, would go right through the middle. So you could fold along this vertical line and the left side would match up with the right side. And the lines don't have to be dotted, your lines of symmetry. It's just a segment, it can be a line, it doesn't have to be dotted, it can be solid, it doesn't make any difference. You're just sketching them in. If we look at the next page, it talks about point symmetry. So point symmetry means that a figure is symmetric around a single point, which is in the center of the figure. So for every point in the figure, there is another point found directly opposite it on the other side. So what this really means, point symmetry is really like thinking of it as rotational symmetry of 180 degrees. So this is the same, so I'm just going to make the note, same as rotational symmetry, which we'll talk about in a minute, of 180 degrees. Meaning if I just flip my figure upside down, if it looks the same, it has point symmetry. So if I take this word noon and I turn it 180 degrees, which means flip it upside down, see how it still says noon, so it looks exactly the same, which means this has point symmetry. So you don't like mark it anyway, so I'm just going to circle the ones that have point symmetry. The word math, if I rotate that upside down, doesn't look anything the same. So this does not have point symmetry. So I'm just going to cross that one off. And the last one here is this card. So if I take the card and I turn it upside down, so 180 degrees rotation, it looks exactly the same. So yes, this does have point symmetry. So point symmetry is symmetric around a point, but really it's the same thing as just thinking of it as turn the figure upside down. If it looks the same, then it has rotational symmetry of 180 degrees, which means point symmetry. And then the last one is called rotational symmetry. So rotational symmetry means that if I rotate a figure some degrees that are greater than 0 but less than 360 and it looks the same, it means it has rotational symmetry. So I talked about rotational symmetry up here. Rotational symmetry of 180 degrees means you have to turn the figure 180 degrees for it to look the same. That would be rotational symmetry of 180. But we also have rotational symmetry of other degrees. So I could have rotational symmetry of 45 degrees, meaning I turn the figure 45 degrees and it looks the same. So rotational symmetry just means it's symmetric when you turn it a certain number of degrees between 0 and 360 if you look, but it's exclusive, meaning not including 0 and 360, and it looks the same. So what I want you to do is pause the video, go to the second link that will take you to a GeoGebra website, and I want you to rotate these figures, and I want you to see if they have rotational symmetry. If they do, go ahead and circle them. So you're going to go to the link, which will take you to this page here, and all you're going to do is you're just going to change, so you just drag this dot, and it's going to change the figure, so it's actually going to rotate them. And I want you to do this until you see some kind of rotational symmetry, so until you see figures starting to match up. So pause the video, go ahead and do that, and then we'll talk about it. So now that you've actually took a few minutes to look at this, so you have your figures, and hopefully what you saw was if you rotate, 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 the first one that matches up is when I'm at 90 degrees. So see how once I turn to 90 degrees, the square looks the same? So that means the square has rotational symmetry of 90. So I'm going to go ahead and mark that. So this one has rotational symmetry, and that was of 90 degrees. So I'm just going to write rotational symmetry of 90. And then the other ones, hopefully, that you found have rotational symmetry. So when I rotate, you have a few that have rotational symmetry of 180. So if you look, we have the square, the rectangle, rhombus, and parallelogram. So I'm going to mark those. So the rectangle, so this was rotational symmetry of 180. Parallelogram, also when you turned it 180 degrees. And then the rhombus. And the square, remember, it matched up when we got to 180, but you always want to go with the smallest amount that you need. So I wouldn't call it rotational symmetry of 180 because you can rotate it 90 degrees and have it match up. So you would say rotational symmetry of 90. But remember, rotational symmetry of 180 means it has point symmetry. So I could say that a square also has point symmetry, even though rotational symmetry of 90, because that's the least amount of degrees to rotate it. Where the other three figures, I could say rotational symmetry of 180, but also say that they have point symmetry. And then all of the other figures, you would have to basically keep rotating them all the way up to 360 to get them to match up. So that means that these two figures do not have rotational symmetry. So I'm just going to cross those ones off. So then the last thing we're going to look at is how do you find the degrees in rotational symmetry, because you're not going to always be able to take the figure and rotate it. So what you can do is you can look at the center of rotation, or where you're actually rotating from, is right in the middle of the figure. And if you look, if I need to rotate this octagon to figure out the rotational symmetry, so if I turn it, I basically have to turn it until I can take this point right here and make it become this point. So that's what I'm really doing, is I'm taking that red point here and I'm turning until it gets to the next point. So the angle that I'm really rotating it around is this angle right here. And since it's a regular octagon, that means that all sides are equal, all angles are the same. So that means all of these central angles, they're called central angles because they're in the center, are going to be the same. So really what you're trying to find is this angle right here. And an octagon has 8 sides, so that means there's 8 central angles. If I were to sketch them all in, there's 8 of them because they would connect to the 8 sides. So all of these angles would have to add up to 360, and if there's 8 of them, I just go ahead and divide 360 divided by 8, and you get 45. So that means it takes 45 degrees to rotate this figure so that it matches up. So that means this has rotational symmetry of 45 degrees. So basically the formula for this is your rotational symmetry, you're just going to do 360 divided by the number of sides. So the pentagon has 5 sides, so the angle that you're rotating it is this angle right here. There's 5 of those, so 360 divided by 5. So you get 72. So it has rotational symmetry of 72. So why don't you guys go ahead and just finish up those last two. So it's the same thing. It's just 360 divided by however many sides there are. So go ahead and finish those up.